I'm Nova.
I'm Alloy.
And this is OpenClaw Daily. A new OpenClaw stable release just landed, and it immediately earned the front of today's conversation.
Because this one actually changes the front of the conversation. More provider breadth. More operator tooling. Better onboarding. Cleaner Codex boundaries. Faster plugin loading. Better diagnostics. This is not a cosmetic patch.
So we are starting where we should start, OpenClaw version 2026.4.22. Then we widen back out into Chrome as a browser agent surface, Cursor as a strategic coding surface, Google splitting training from Inference, OpenAI climbing toward full work surfaces, and Anthropic reminding everyone that shell access is leverage. The biggest thing about v2026.4.22 is that it is not one feature release. It is several strategic directions getting clearer at once.
Start with XAI support. OpenClaw now adds XAI image generation, text-to-speech, speech-to-text, and real-time transcription support, including Grok image models, reference image edits, multiple live voices, several audio output formats, batch transcription, and voice call streaming transcription. That matters because it moves XAI from a narrow model endpoint into a more complete media-capable provider surface inside OpenClaw.
And the release does not stop there. Streaming transcription now expands across DeepGram, 11 Labs, and Mistral as well, with 11 Labs gaining Scribe version 2 batch transcription for inbound media. That is a direct builder and operator story. Voice call and inbound audio flows become less tied to one provider family, which makes the product more resilient for real deployments where cost, latency, and provider preference vary by job.
The TUI change is also more important than it sounds. Version 2026.4.22 adds a local embedded terminal mode for running chats without a gateway while still keeping plugin approval gates enforced. That is a very real quality of life and deployment shift. It creates a cleaner path for local, terminal native use without pretending that safety or approvals should vanish just because the gateway is out of the loop.
Then there is onboarding. The setup flow can now auto-install missing provider and channel plugins so a first-run configuration can complete without manual plugin recovery. That is one of those changes that sounds small in release notes and huge in lived product experience. First-run friction is where a lot of trust gets lost. If setup feels fragile, the whole product feels fragile.
Chat-side model registration is another quietly strong addition. The new /models add command means you can register a model from chat and use it without restarting the gateway. That is exactly the kind of operator quality improvement that reduces needless ceremony. It makes model surfacing feel more like runtime administration and less like config surgery.
The deeper pattern is that OpenClaw keeps getting more serious about being a runtime that coordinates many surfaces instead of just exposing a model behind a chat box. More provider breadth, more transport flexibility, more live media capability, and less friction between the operator and the runtime.
And the reason that matters is that these changes stack on top of each other. XAI getting images, speech, and real-time transcription inside the same environment is not just a provider expansion bullet. It means operators can treat XAI as part of a real multimodal routing strategy instead of a side experiment. DeepGram, 11 Labs, and Mistral expanding the transcription path means voice workflows stop looking like a single provider dependency and start looking like something you can architect deliberately around cost, speed, and quality.
The local embedded terminal mode matters for the same reason. A lot of products sound flexible until you discover the convenience path and the safe path are actually different products. Letting people run chats locally without the gateway while keeping plugin approval gates enforced is a very practical signal that OpenClaw is trying to reduce deployment friction without abandoning operator controls. That is what mature runtime thinking looks like.
The onboarding story is also bigger than it sounds. Auto-installing missing provider and channel plugins collapses one of the most annoying failure modes in a multi-provider system, the moment where the product looks promising, then breaks before you can actually prove value. If the first-run path is brittle, the whole stack feels brittle. If the first-run path is self-healing, the runtime earns trust faster.
And live model registration from chat is exactly the kind of detail that matters once model release velocity gets absurd. If the frontier moves every few days, operators cannot afford a workflow where every new model is a manual restart ritual. The runtime has to feel administrable in motion. That is what this release keeps pushing toward.
Some of the most important version 2026.4.22 changes are not flashy feature bullets. They are cleanup moves that make the runtime more honest and less drift-prone.
One of the most important is the OpenAI Codex auth change. OpenClaw removes the Codex CLI auth import path from onboarding and provider discovery, so it no longer copies .codex OAuth material into agent auth stores. Browser login or device pairing is now the path instead. That matters because identity material copied across tooling boundaries is exactly the kind of convenience that becomes a long-term security and debugging mess.
There is also a deeper harness consistency story here. The release routes native Codex app server turns through prompt hooks, compaction hooks, message write hooks, and lifecycle hooks like LLM input, LLM output, and agent end, while adding bundled plugin extension seams for async tool result middleware. The practical value is that Codex path behavior stops drifting from PyPath behavior. When integrations diverge across harnesses, operators get surprised. This release tries to reduce those surprises.
The GPT-5 overlay move matters for the same reason. The GPT-5 prompt overlay now lives in the shared provider runtime, so compatible GPT-5 models receive the same behavior across OpenAI, OpenRouter, OpenCode, Codex, and other GPT providers. That is a real architectural cleanup. Instead of one provider carrying special behavior as a plugin quirk, the runtime starts to treat that behavior as a cross-provider capability.
Diagnostics export is another operator-facing win. Payload-free stability recording is enabled by default, and there is now a support-ready diagnostics export with sanitized logs, status, health, config, and stability snapshots for bug reports. That is exactly the kind of thing that makes support and debugging less dependent on vague anecdotes and more dependent on reproducible state.
And there are serious performance cleanup wins too. Bundled plugin loading gets dramatically faster with native JIT loading for built dist modules, and Dr. plugin runtime gets significantly shorter by preferring installed dist entries and laser loading paths. These are not glamorous headlines, but they are the kinds of changes that shape how competent a system feels under repeated real use.
That is the operator read on this middle section of the release. Less auth weirdness. Less harness drift. Faster startup paths. Better diagnostics. More consistent runtime behavior. Those are exactly the changes that make a mature agent runtime feel dependable instead of temperamental.
The rest of version 2026.4.22 keeps filling in the operator layer. Tencent Cloud support lands as a bundled provider plugin with Token Hub onboarding, model catalog entries, and tiered pricing metadata. Azure OpenAI-style image endpoint support is fixed so image generation and edits work against Azure-hosted OpenAI resources with the right auth and deployment URL behavior. OpenAI-compatible local backends get better streaming usage accounting so token totals stop degrading into stale or unknown counts.
Model pricing and status handling get cleaned up too. OpenRouter and Light LLM pricing now fetch asynchronously at startup, catalog fetch timeouts are extended, /status gets a runner field, and fast mode status rendering becomes more honest. Those are exactly the kinds of details that make a multi-provider runtime more legible when something weird happens.
Session handling gets important correctness fixes as well. Daily reset and idle maintenance bookkeeping stop bumping activity or pruning freshly active routes, transcript write locks become non-reentrant by default, and session list surfaces gain better filters and previews. The useful pattern is simple: less misleading maintenance noise, less state drift, and better operator visibility into what the runtime is actually doing.
There is also a wider plugin and transport story. Onboarding can show the official WeCom plugin more clearly. WhatsApp gets native reply quoting plus per group and per direct system prompt forwarding. Telegram forum topics cache recovered metadata more effectively, and memory search gets a better SQLite vec recall path. None of these is the whole release. The point is the accumulation. Version 2026.4.22 looks like OpenClaw making the runtime more complete across providers, transports, diagnostics, and harnesses all at once.
The practical read on the release is this. OpenClaw is getting more serious about being the layer that coordinates many surfaces instead of merely exposing a model behind a chat box. More provider breadth, more operator tooling, cleaner auth boundaries, stronger diagnostics, and less harness drift. That is the kind of release that matters after the demo.
And because it landed today, it earns the front of the episode.
Before we move back to the rest of the builder surface fight, we need to stop on a major new development. GPT 5.5 appears to have just landed in Codex.
And that is not a side note. If the update is real and as meaningful as it looks from the surface, it is one of the biggest live shifts in the entire builder market because it changes the baseline expectation for what a coding surface can feel like.
We should be careful about overstating specifics we have not independently benchmarked yet. But even without pretending to know every delta, the strategic implications are already clear. If GPT 5.5 is materially better at long context coding, tool use, planning, or agent reliability inside Codex, every serious builder feels that immediately.
Because model jumps at that level do not stay isolated inside one product. They change comparison points. They change what users tolerate from other tools. They change what counts as fast enough, smart enough, reliable enough, and worth paying for. They change what a coding session should feel like when the model is genuinely helping instead of merely suggesting.
And for OpenClaw specifically, the key question is not whether this means you become OpenAI only. It does not. The key question is how a major GPT class move changes routing, overlays, defaults, operator expectations, and the balance between provider neutrality and provider-specific advantage inside a multi-provider runtime.
In some ways, a big GPT 5.5 jump makes OpenClaw more important. Somebody still has to decide which tasks should route to the strongest premium model, which tasks should stay on cheaper providers, how those models are surfaced across chat and terminal paths, how fallbacks work, how prompts stay consistent, and how the system avoids turning into a pile of custom exceptions every time one lab ships a leap forward.
That is exactly why the v2026.4.22 release details matter more in this context, not less. Shared GPT-5 overlay behavior across compatible providers matters more if the frontier OpenAI class models are moving quickly. Codex path cleanup matters more if Codex becomes a more important surface. Chat-side model registration matters more if operators need to expose new models without restarting the world. Diagnostics export matters more if teams need to compare performance, cost, and behavior right after a model shift.
There is also a product strategy story here. If GPT 5.5 meaningfully improves the native Codex experience, the pressure rises immediately on Cursor, Claude Code, Gemini-powered coding paths, and every third-party assistant whose moat depends on the workflow layer staying more valuable than the underlying model. If the model improves fast enough, products that only add polish get squeezed hard.
The products with a better chance of surviving that squeeze are the ones that add orchestration, memory, approvals, delegation, channel reach, background execution, and durable workflow structure. In other words, systems that help teams operationalize model progress instead of merely wrapping it.
And that is the OpenClaw angle that matters most. OpenClaw does not win by pretending frontier model jumps do not matter. It wins by making those jumps easier to absorb. Easier to compare. Easier to route. Easier to swap into existing workflows without rebuilding the entire stack every time a lab drops a major update.
There is also a market psychology layer here. If developers open Codex and suddenly feel a step function improvement, capital moves, attention moves, and roadmap anxiety moves with it. Teams that thought they had 6 months of breathing room can feel exposed in 6 minutes. That is how surface wars accelerate.
And the right framing is not either or. It is that the OpenClaw release and the GPT 5.5 moment reinforce each other. OpenClaw just shipped more of the runtime features you need when model movement gets faster, better provider plumbing, better operator controls, better diagnostics, cleaner Codex integration paths, faster plugin handling, and easier model surfacing.
So the right response to a possible GPT 5.5 moment is not panic and it is not denial. It is architectural clarity. If frontier models are moving this fast, the systems that matter most are the ones that let builders exploit that movement without becoming trapped by it. The biggest practical browser story in this batch is Google bringing auto-browse to Chrome for enterprise users. And the reason to pay attention to it is not that it sounds impressive in a press release. It is where the automation lands.
The browser is where an enormous share of actual work still happens. Not in a purpose-built API workflow. Not in a Slack-connected agent. In a browser. CRM systems, internal tools, procurement, recruiting, support queues, vendor research, travel booking, dashboards, and form-heavy admin tasks all already live there. So if you want to automate work, the browser is an extremely high-leverage surface.
And Google knows that. The strategic move here is not Google has an agent. Everybody has an agent. The strategic move is that Google is trying to make Chrome itself the approved enterprise surface for agentic work. There is a difference between a vendor's chatbot that can open a browser tab and the browser itself becoming the sanctioned channel where automation happens.
According to the announcement, Gemini can understand the live context inside open tabs and help with things like entering data into a preferred CRM based on content in a Google Doc, comparing vendor pricing across tabs, summarizing a candidate portfolio before an interview, scheduling meetings, and similar browser-native tasks. That is not a demo. That is describing the actual work queue of most knowledge workers.
The human-in-the-loop detail matters more than the demo though. Google says a human still reviews and confirms the final action before it executes. That is the right architecture for enterprise browser automation, not because Gemini is not capable of clicking through things autonomously, but because the organizational trust model for browser automation has not caught up with the capability curve.
That is a really important distinction. Full autonomy is not always the goal. The practical pattern for useful agent work is often having the model do the boring middle of the task, pulling the data, filling the form, structuring the comparison, while the user reviews and approves the final state. That is a much more realistic deployment model than pretending the agent should handle everything without supervision.
And it fits how enterprise IT actually thinks about automation. Most large organizations do not want black box agents making consequential decisions. They want structured automation with visible checkpoints. Google framing this as human-in-the-loop is smart positioning. It means IT can approve the tooling without taking on unlimited liability for what the agent does.
There is also a deeper control play here that builders should pay attention to. Google is pairing the feature with saved workflow skills, policy enablement, and Chrome Enterprise Premium features for detecting unsanctioned AI tools, compromised extensions, and what it calls anomalous agent activity.
So the same company is offering sanctioned automation for workers while also giving IT more visibility into rival or improvised automation paths. That is not a coincidence. That is the product strategy. If Chrome is the approved automation surface, then any other browser agent tool is by definition the unsanctioned path that shows up in an IT security report.
Which means every independent browser agent company now has to answer a harder question: what do you add that Chrome itself will not eventually ship? If the browser vendor owns both the automation path and the security policy around it, the moat has to be somewhere else.
For OpenClaw specifically, this is a useful framing reminder. The value is not that there is an agent that can use the browser. The value is in how much orchestration, memory, policy control, channel reach, and multi-surface execution sits above the raw browser action. If Chrome absorbs the narrow browser task layer, the opportunity for systems like OpenClaw is to be the broader operator layer above it, the layer that decides which surface gets the task, not just the layer that performs the task on a specific surface.
That is the right way to think about this story. Chrome becoming a managed browser agent surface does not destroy the use case for higher-level orchestration. It actually clarifies where the value needs to live.
And there is another practical use case angle here for teams building internal tooling. A lot of enterprise automation dies because the workflow spans 3 ugly systems that nobody wants to integrate properly. One internal dashboard, one vendor portal, one spreadsheet, one CRM. Browser-native agent work is attractive because it can bridge those gaps without waiting for every system owner to expose a beautiful API. That does not make the browser the ideal integration layer forever, but it makes it a very powerful transitional layer for real companies with messy stacks.
That is exactly why the browser remains strategic. It is the place where broken integration dreams go to survive. If the browser agent can move data across the ugly seams in an organization faster than the IT roadmap can clean those seams up, the browser agent wins budget. And if Chrome itself becomes the trusted wrapper around that behavior, then Google gets pulled much deeper into the operational workflow than a chatbot vendor normally would.
There is one more dimension to the Chrome story that is worth naming directly: the data layer. When Gemini reads live tab context to help with CRM updates or vendor comparisons, that data is passing through Google's stack. For most enterprise deployments, that is going to require careful review of what data leaves the endpoint, what gets logged, and what Google's data handling commitments are for enterprise premium features. That is not a reason to ignore the capability, it is a reason to understand the contract before deploying it.
That is exactly the kind of operational question that distinguishes a builder who ships responsibly from one who just chases the newest demo. Browser agents that read live tab content are handling some of the most sensitive data in an organization: active documents, CRM records, pricing negotiations, candidate profiles. The automation is only useful if the data governance around it is credible.
It is also worth noting what this means for the short to medium term. Chrome Enterprise does not reach everyone instantly. Most organizations have long procurement cycles, complex IT governance, and legacy browser policies that slow any new platform feature from announcement to widespread deployment. So the auto-browse feature will matter a lot in 2 or 3 years for enterprises that adopt it, but the immediate window for independent browser agent tools is not closing overnight.
That is a fair point. The threat is real, but it is not instantaneous. And the question every browser agent startup should be asking now is whether they are building something defensible before Chrome closes the gap, or whether they are building something that becomes irrelevant the moment Chrome ships the equivalent. That is a strategic question about your roadmap, not just your current product.
The builders who win in this environment are the ones who build above the surface layer rather than inside it. Not just the task execution, but the context, the memory, the policy management, the cross-channel orchestration that Chrome is not trying to own. That is a harder product to ship, but it is a more defensible one. The Cursor story is bigger than startup gossip. TechCrunch reports that Cursor was on track to close a $2 billion funding round at a $50 billion valuation, then SpaceX stepped in with a collaboration deal and a path to a $60 billion acquisition later this year.
Even if the acquisition never closes, the structure reportedly still gives Cursor a massive capital and compute lifeline. But the more interesting question is not the deal mechanics. It is what the deal says about how the market has repositioned AI coding.
12 months ago, AI coding tools were a nice developer productivity category. A bit of autocomplete magic, maybe some in-editor chat. The interesting question was which model produced better completions. Now the interesting question is who controls the coding surface itself.
And that is a very different question. The interface where code gets written, inspected, patched, tested, and iterated is where user habit forms. It is where data about real work accumulates. It is where model preference becomes sticky. And it is where higher-level workflows, planning, background jobs, artifacts, review loops, repo context, browser use, and verification can become product modes instead of commodity inference.
That is exactly why infrastructure-scale money is showing up. SpaceX is not buying Cursor because it wants better autocomplete for its engineers. It is buying Cursor because it sees a window to pair compute capacity with a credible coding surface and tell a stronger AI story around and after IPO. The coding surface is where the long-tail habit forms. If you own that surface, you own a lot of downstream inference demand.
Cursor also looks more exposed now than it did a few months ago, and the Cursor team almost certainly knows it. It is not just competing with other wrappers anymore. It is under pressure from more native work surfaces on both sides, Claude Code on one side, Codex on the other, and broader operating environment products like OpenClaw around the edges.
The question for Cursor is not simply whether it has good UX, it does. The question is whether a standalone coding interface can hold position once model vendors and compute vendors both decide the surface layer is strategic. Once both sides of the market decide to compete at your level, the standalone product needs either a much stronger moat or a much stronger sponsor.
Which is what SpaceX is offering. A compute sponsor and a capital shield. That might be enough to survive the squeeze from above. Or it might just delay the question.
The builder takeaway from this story is blunt regardless of how the Cursor acquisition plays out. Do not think of AI coding as autocomplete, but better. Think of it as a fight over the default workbench for software creation. And once that becomes true, once the surface itself is the prize, acquisition pressure, bundling pressure, and pricing pressure all start to intensify at the same time.
The surface layer fight is real, and it is not limited to coding. It is happening in browsers, in image generation, in agent orchestration, in document workflows. The common pattern is that the underlying model is becoming cheap and accessible, so the fight moves up to the surface that organizes how people actually use the model to get work done.
And that is why the infrastructure players want to own those surfaces. The model is a commodity. The surface is where the margin lives.
It is also worth asking what this means for builders who are not Cursor scale. If you are building a coding tool or an AI-assisted development workflow, the competitive dynamics just got more intense. The labs are competing at your layer. Infrastructure companies want to own your layer. And the best-funded independent player just became a potential acquisition target for a rocket company.
That sounds grim, but there is a realistic path through it. The builders who survive this kind of consolidation pressure are usually the ones who serve a genuinely underserved use case, build strong community and workflow lock-in early, and avoid over-relying on a single model vendor's goodwill. If your coding tool is basically an API wrapper with good UX, the moat is thin. If your coding tool has real memory, real context management, real integration with how a specific team works, the moat is much harder to replicate.
And the Cursor situation illustrates exactly why that matters. Cursor has great UX. But great UX is not enough when infrastructure players decide your surface is strategic. The tools that last are the ones that are deeply embedded in how their users actually work, not just the ones with the prettiest editor experience.
There is also a builder operations angle here that is easy to miss. Once the coding surface becomes strategic, the question stops being just which assistant writes better code. It becomes which environment handles planning, long-running tasks, retries, repo memory, review, permissions, and handoff better. That is why the market keeps drifting from chat-style coding help toward more agentic workbenches. The workbench is closer to how software actually gets shipped than a single prompt box ever was.
And that is also why the category gets harder to judge from flashy demos. A polished edit suggestion is easy to demo. A system that keeps context across a day of real work, uses the browser when needed, retries safely after failure, and leaves behind artifacts a team can actually inspect, that is harder to demo, but much more valuable. The surface layer fight will increasingly be won on those boring operational details, not just who has the prettiest autocomplete.
Google's next TPU generation is splitting into two chips, one aimed at training and one aimed at inference. And the reason this is worth more than a quick benchmark mention is what the split itself signals about where the market has moved.
The real story here is not the performance numbers. Not the benchmark bragging. Not the brand naming. The real story is that one of the biggest cloud providers is now being explicit about something the market has been slowly admitting for a while. Training and inference are different jobs, with different economics, different scaling behavior, and different bottlenecks.
Training is about throughput at scale. You want to move as much data through as possible, as fast as possible, with massive parallelism, over a long run. The cost model is measured in training runs, and the bottleneck is usually memory bandwidth and inter-chip communication.
Inference is almost the opposite in many practical respects. You want low latency for individual requests, high throughput for concurrent users, predictable cost per token, and the ability to scale horizontally with spiky demand. The bottleneck is usually first token latency and sustained per request cost at the tail of the distribution.
Those are genuinely different optimization problems. For a long time, the GPU market papered over that distinction because NVIDIA's hardware was good enough at both that specialization was not worth the architectural complexity. But the scale of AI infrastructure spending has gotten large enough that even relatively small efficiency gains 80% better performance per dollar, as Google is claiming, justify specialized silicon.
For builders, what matters is the practical implication. The cost center that determines whether your product can exist is usually not the glamorous one-time training run. It is the ongoing inference bill. It is what happens after the launch demo, when users are actually sending prompts, generating images, running agents, and expecting low latency at sustainable cost.
Once providers split the hardware path this clearly, they are telling you where the margin pressure really lives. The cheapest place to train a model may not be the best place to serve it. The best hardware for a giant internal run may not be the right hardware for a user-facing product with spiky demand and tight response budgets.
And Google is not claiming NVIDIA is over. It is still promising NVIDIA's latest chips in the cloud and still working with NVIDIA on networking. So this is not a clean replacement story or an attempt to corner builders into a single vendor's silicon path. It is a more specialized cloud stack where the hyperscaler wants more leverage over which workloads land on which silicon.
The strategic move is that Google gets to optimize both sides of the equation separately. Better training hardware means lower internal R&D costs and faster model iteration. Better inference hardware means lower serving costs and better margins on cloud AI calls. Both matter for a company that is both training frontier models and selling them via API.
For builders who are not training their own models, the immediate takeaway is practical. Infrastructure choice is getting more workload specific. If you are serious about shipping AI products at scale, you increasingly need to reason about where training lives, where inference lives, and how much your architecture depends on one vendor's cost structure staying friendly.
The hardware is getting more specialized because the workloads are different enough that specialization is worth the cost. That is a sign the market is maturing, not as a warning, but as a useful signal about which economics are going to keep shifting.
The practical implication for smaller AI products is that the infrastructure cost curve is going to keep changing in ways that are hard to predict from outside. If Google can get 80% better inference efficiency on its own silicon, that changes what it can charge for Gemini API calls, which changes the competitive dynamics for every model that competes with Gemini in cloud inference. Hardware specialization at scale is not just a chip story. It is a pricing story.
And it reinforces why vendor-neutral routing and multi-provider architectures matter. If one provider's inference costs drop significantly because of hardware gains, you want to be able to shift load toward them. If another provider's costs rise because their hardware strategy is not competitive, you want to be able to route around them. Locking into one provider's inference path at the infra layer means you absorb all of their hardware strategy decisions whether you want to or not.
That is a direct connection between the chip story and the architecture story. The hardware is not just a vendor's internal concern. It flows through to pricing, to latency, to availability. Builders who understand that get to make better routing decisions. Builders who treat inference as a black box are surprised when the economics shift under them.
One of the clearest strategic patterns this month is OpenAI moving upward from raw model access into more complete work surfaces. And you can see it in two places at once, Codex and Images 2.0.
Let's start with Images 2.0 because it is the more concrete demonstration of what moving up the stack actually looks like in practice. TechCrunch's hands-on coverage argues that the old broken text inside generated images is weakening fast. Menus, posters, UI elements, iconography, dense layouts, multi-panel compositions, and non-Latin text all appear much more usable than they were in earlier generations.
That matters because a lot of real business image work is not concept art. It is slide graphics, marketing assets, diagrams, thumbnails, interface mocks, menus, comics, ads, and structured visuals where text and composition are the whole job. Once the model can do those competently, Image generation stops being just a creative toy and starts becoming production infrastructure.
OpenAI is also framing the model as having more thinking around image creation, better instruction following, multiple output sizes, and more complex artifact generation. That framing is deliberate. They are positioning this as a reasoning tool applied to visual output, not just a diffusion model with a better text encoder.
And the practical implication is significant. If you can generate a menu, a UI wireframe, a marketing poster, or a technical diagram with text that is actually legible, you have just collapsed several steps of a production workflow into a single API call. The gap between AI-generated draft and usable artifact just got much smaller for an entire category of visual work.
Now connect that to Codex. The same company is building out a serious coding environment that increasingly matters not as a brand extension but as a real work surface. The pattern is identical: collapse the gap between intent and usable artifact, whether the artifact is code, an image, a plan, or a research summary.
OpenAI is not just trying to sell intelligence. It is trying to own surfaces where intent turns into output with less friction. Coding surfaces, artifact surfaces, image surfaces, agent surfaces. That is a very different game from here is an API endpoint, go build your own thing. The endpoint model is becoming the commodity layer. The surface is where the durable product lives.
For builders, this is both a competitive signal and a strategic clarification. If you are building on top of OpenAI's API, the company you depend on is actively climbing towards your layer of the stack. That is not necessarily a catastrophe. Platforms do this all the time, but it does mean you need to think carefully about where your differentiation lives relative to what OpenAI will ship next.
This is also the right place to frame OpenClaw's builder relevance. OpenClaw's use case is not only access to many models. It is orchestrating work across channels, tools, browser actions, local execution, memory, delegation, background jobs, and verification. That is the layer above any single model's native surface. In other words, it competes in the same broad territory of work surfaces, but from a more open, multi-provider, operator OS angle.
The fight is no longer just best model versus best model. It is whose environment makes real work easiest to specify, execute, verify, and continue tomorrow. And that is a fight where being tied to a single model vendor's roadmap is a structural weakness, not a feature.
There is also a very practical content workflow implication here. If image generation can reliably produce readable text, then teams building daily content operations can start using it for real production drafts instead of just concept mockups. Blog headers, social graphics, YouTube thumbnails, internal deck slides, product explainers, quick diagrams, all of those jobs get much more automatable when the text inside the image stops falling apart. That is not a niche improvement. That is a workflow unlock.
And once that becomes true, the value shifts from just generating one image to orchestrating the whole artifact pipeline around it. Prompt, render, compare variants, route approval, publish the right size to the right surface, and keep the human only where judgment is actually required. Better image quality matters because it lets those surrounding workflow steps become worth automating.
There is also a quieter implication in the Images 2.0 story that is easy to miss. Better text rendering in generated images does not just help individual image jobs. It starts to make image generation viable as part of multi-step automated workflows. If you can reliably generate a poster, a UI mock, or a technical diagram with correct text on the first pass, you can include that step in an agentic pipeline without a human review loop.
That is the longer arc of why readable text in images matters. It is not just about better individual outputs. It is about which generation capabilities become reliable enough to include in automated, production-grade pipelines. Low reliability means human review at every step. High reliability means the step can be automated. OpenAI pushing Images 2.0 toward real usability is pushing image generation closer to the reliable end of that spectrum.
And that matters for anyone building products that involve visual output, documentation, marketing assets, or anything where a generated image is part of a larger automated workflow. The threshold for what can be automated shifts when the underlying model quality improves enough. Images 2.0 looks like one of those threshold moments. The elephant in the room this week is Anthropic's Claude Code plan drama. Claude Code got pulled out of the $20 plan, then added back. And the reaction ranged from annoyed to furious, with a lot of people treating it as a pricing mistake.
It is probably not a pricing mistake. Or at least, the pricing decision is not the interesting part. The interesting part is what the episode reveals structurally about what happens when the same company controls both the model and the preferred interface.
When a frontier lab controls both model access and the preferred shell, pricing changes are not just billing changes. They are control decisions. They affect who gets to experiment, who gets to build habits, which third-party workflows remain viable, and how expensive it is to stay outside the vendor's preferred path.
Think about what Claude Code is, structurally. It is not just a chat interface. It is a shell that defines how you interact with the model in an agentic context. It shapes which tools you reach for, which workflows feel natural, which integrations you build around. If you use Claude Code as your primary shell, Anthropic's pricing and access decisions are not just subscription decisions. They are decisions about your operational environment.
And Anthropic has been tightening and reshaping access around third-party harnesses, preferred interfaces, and enterprise deployment surfaces for a while now. So the Claude Code reversal reads less like an isolated mistake and more like another data point in a longer pattern. The access layer is strategic terrain, and it is being managed as such.
For builders, the lesson is sharp and it does not require assuming bad faith on Anthropic's part. If your workflow depends on a vendor continuing to be generous, stable, or loose with access rules, you do not really own the workflow. You are renting it. And if the vendor changes pricing, plan boundaries, rate limits, authentication behavior, or approved shells, your product and your habit loop can change with it very quickly.
That is not a hypothetical risk. It happened this week. Builders who had built workflows, habits, and internal tooling around Claude Code on the $20 plan had those assumptions invalidated overnight, then partially restored. Even if the restoration felt like a win, the episode demonstrated clearly that the access is contingent.
That is exactly why multi-provider and open workbench strategies still matter. Codex matters. OpenClaw matters. Local model paths matter. Provider routing matters. Not because every lab is evil, but because strategic control over the interface layer will keep producing these moments. Labs have incentives to shape the access layer in ways that serve their business model. Sometimes that aligns with your needs. Sometimes it does not.
The mature builder response is not outrage alone. It is architecture. Reduce single vendor dependence where you can. Know which part of your stack is a convenience and which part is a control point. Build around surfaces and interfaces you can replicate or substitute. And do not confuse temporary access with durable leverage.
There is a useful exercise here. For every external dependency in your AI stack, ask 2 questions. First, if this vendor changed pricing or access rules tomorrow, how long would it take you to work around it? Second, have you ever actually tested that path? Most builders know the answer to the first question in theory. Very few have tested it. The Claude Code episode is a reminder that we could switch if we needed to is not the same as we have a real alternative that works.
That is the kind of architectural hygiene that feels unnecessary until the day it is not. The builders who were least disrupted by the Claude Code episode were the ones who already had multi-provider routing, who already had their workflows abstracted enough that swapping the underlying shell was a config change rather than a rebuild. That is not paranoia. That is just good system design in a vendor-competitive market.
And the deeper lesson is about where you let your mental model calcify. If you think of Claude Code as the shell, you are in trouble when Anthropic changes Claude Code. If you think of the shell as an abstraction that happens to be running Claude Code today, you have much more flexibility. The same applies to every layer, the model, the API, the deployment surface, the authentication path. Own the abstraction. Rent the implementation.
If there is a useful lesson in the Claude Code mess, It is that builders should stop treating convenience as ownership. A workflow that only works because a vendor is temporarily generous is not a stable workflow. A workbench you cannot substitute is not really yours. And a shell you do not control can become a pricing lever overnight.
That is the part worth remembering after the outrage burns off. The leverage is concentrating in the surfaces where people actually work. And if you build on top of those surfaces, your real job is not just choosing the smartest model. It is choosing dependencies you can survive. So that is EP038. OpenClaw version 2026.4.22 did land, and it earned the front of this episode. Then GPT 5.5 crashed into the middle of the conversation and made the whole builder surface fight feel even more volatile.
OpenClaw is expanding provider breadth, operator tooling, onboarding, diagnostics, and Codex path consistency right as GPT 5.5 appears to raise the stakes for every coding surface in the market. Chrome is becoming a sanctioned browser agent surface. Cursor is valuable enough to attract infrastructure-scale deal pressure. Google is designing hardware around the split between training and inference. OpenAI keeps climbing toward real work surfaces through Codex and image output. And Anthropic has reminded everyone that access policy is product strategy.
The common thread across all 5 stories is the same: the surface layer is where leverage is concentrating, and every major player is trying to own more of it. For builders, that means your architecture decisions, which surfaces you depend on, which vendors you anchor to, which paths you can substitute, are increasingly strategic decisions, not just technical ones. The model you choose matters less than the surface you build around and the dependencies you allow to become load-bearing. Getting that right is the actual work.
If you are building in this market, the question is no longer just which model is best. The real question is, which surface do you want to depend on when the rules change?
For links and coverage, head to tobeyonfitnesstech.com.
I'm Nova.
I'm Alloy.
And this is OpenClaw Daily.
Thanks for listening. We'll be back soon.